I already changed it, son. I already changed that. No need to worry. Where was I? Oh, that's the wrong button. Ah, that's where it was. It was hiding. Click download SDK. Options once you do the flutter install page if you have not installed Git for Windows. That's right. Clone flutter. So it's still installing. It's gonna take a few minutes. It says. It wants Chrome, ain't no way. IntelliJ IDE. Flutter needs IntelliJ IDE Ultimate Edition. Alright, I think installation is done. Perhaps. Let's do Flutter intro. Bat that. Bat that. Strict hours. It's like combining two random words. And then liking and then keeping track of the favorites. Okay. Should be easy enough to start out. Let's see. The provider. Build user. So these are packages. That's documentation. This is also packages. What is this? Start building web. just did that. So now I can close that. Let's do first Flutter app. Initial complete.
Hey there! In this Colab, you're going to build this app. This, I call it Namer. It is an app that just...
And here is Philip, taking you through the whole Colab. Alright, Philip. Set up your environment. Download Visual Studio Code, then choose a development target. You can run on the following operating systems. Yes. Your app can run on the following operating systems. Oh. So runs the Windows, choose Windows as a development target. We've installed SDK already. Should be good. Alright. That seems all good. Okay, got it. Flutter application 1. Oh, it was doing more. Oh no. just a visual bug. Main Dart. Okay, everything is open. And then that. Replace the content of this file. Okay. If your app name other than namer app, you need to change the first line correspondingly. Well, of course. Next, open analysis options. YAML. This is just versions. Replace its content with the following. Linter with some rules. Alright. I see. Alright. We're in the main. Okay. So main function class scaffold. Material app title, team, use material tree, alright, color scheme, home page. These are the different operating systems. iOS, Android. Alright. At the bottom right corner of the code, you'll find a button that shows the target device to change it. Bottom right, target device. Yeah, show it. That's some crazy crispy quality. Which was it? There. Okay. Oh, it says Windows. Okay. Current device, Windows. Mac OS desktop. Okay. Does it say no? Okay, we're on this device. Let's activate it and run it. Doesn't look like much yet. Okay. It's still opening or building. A random ID, rear word. Okay, we got it. Right. Wait. I'm gonna get some water. Wait, where is this? Oh, it's behind it. BRB. Alright, we back. Lol. The difference was the letter S. That's why why it wasn't working before. Lol. Color. Or you could just do like that. Probably. Oh yeah. Oh. Oh yeah. It all changes. That's nice. Yeah.
Hey there, folks. Rob here. Welcome back to the show. So today I wanted to talk a little bit about screen readers. Screen readers are super important for many of our users out there, but I know a lot of developers are not familiar with these pieces of technology. And that's kind of a bummer because screen readers are actually pretty easy to pick up. And if you're using a computer like a Mac, you've already got a screen reader built in for free. So what I wanted to do today was focus on the screen reader that comes with the Macintosh computer. And then in the next episode, we'll look at some free screen reader options for Windows users. So on the Mac, the screen reader that we've got built in is called VoiceOver. And if you follow me over here to my laptop, I'm going to go to my system preferences. I'm going to go to the accessibility setting right here. And then there's a tab. I'll zoom in a little bit so you can see it. So there's a little tab over here for VoiceOver. And click on that. And there's a few options that we have. Welcome. Most developers are going to need to know. The first thing is this idea of the, and it's going to present some instructions. It's about 22 little slides that you can click through. Okay, so I'm going to do VoiceOver training. Now, I highly recommend everyone take maybe about 20 minutes to go through this. Go to my free. So what I wanted to do today was focus on the screen reader that comes with the Macintosh computer, and then in the next episode, we'll look at some free screen reader options for Windows users. So on the Mac, the screen reader that we've got built in is called VoiceOver. And if you follow me over here to my laptop, the rotor, just to, jump the word Udacity or Udacity, leave the quirks in place. They're used to the way that the tool works already.
Hi, everybody. My name's Dan Field. I'm a software engineer with the Flutter team.
Hi, my name is Victor Saran. I'm a technical program manager at Google working on accessibility in material design. You hear us talk a lot about accessibility, but actually what does it mean? Well, there's many definitions. I would send you to Wikipedia, but I'll spare you some time. What we mean here today is accessibility is when user interfaces are usable by anyone, including people with disabilities. According to World Health Organization, there are about over 1 billion people with disabilities in the world. Some of the examples include, for example, people who are completely blind or have some vision, for example, like myself, and I still can do things with the computer. I can use my mobile phone. In fact, I do my job at Google, thanks to technology. Also, people who are hard of hearing, they cannot hear anything or they can hear some. Also, people who have physical disabilities, they can't use their hands to type on a keyboard. Or actually, anyone. Some of you may have gotten into some what we call temporary disabilities, where you may have injured your arm or while doing skateboarding or whatever else you guys like doing. So these things happen to all of us, and technology is here to save us in some ways. And we've been using technology since ancient times to improve the lives. For example, we invented the wheel, fire, typewriter, smartphone, and so on and so forth. And accessibility is a way to make technology work for everyone, including people with disabilities. Specifically for Flutter, why we're really so passionate about accessibility in Flutter is because Flutter is this cross-platform solution that reaches millions of users out there. And through implementing accessibility in a consistent and friendly way for different platforms, we can make it easier on developers as well as for users to ensure that they have a consistent experience no matter which platform they're on.
Thanks, Victor. So how does accessibility work in Flutter? There's a few different areas to think about when you think about accessibility. It could be things like text contrast for screen readers, tap targets, the size of things that you want users to be able to interact with on your screen. At a basic level, really easy way to break this down is when we think of Flutter, I think we tend to think of the widgets that we create for our app. And up on the screen here, I have a screenshot of the Hello World Flutter app that you're probably familiar with if you've ever done a Flutter Create application starting out. Each of these widgets corresponds to some number of semantic tree nodes. So we have the widgets tree, and we also have a semantics tree. Up on the screen here, you can see that we have our header with the Flutter demo homepage, which will have a semantics node that will say Flutter demo homepage, and it's annotated as a header. In the middle of the screen, you have pushed the button this many times. There's another node with 1 as the counter for the number of times you push the button. And then down towards the bottom, there's that floating action button, which has a increment tooltip or label on it, and that will also get annotated as being a button. The widget tree does not necessarily correspond one-to-one with the semantics tree in Flutter. So some nodes may get merged in, some number of widget nodes may get merged into a single semantic node. Or you might have the opposite, where what you think of as a single widget, you actually want read out as more than one semantic node for some reason. For example, that header node up at the top, that's an app bar with a text child, that all gets one semantic node. The two pieces of text in the middle, they're each getting their own semantic node. That button down at the bottom is actually multiple widgets composed together for the shape of the button, that it's a button. Semantic node. Or you might have the opposite, where what you think of as a single widget, you actually want read out as more than one semantic node for some reason. For example, that header node up at the top, that's an app bar with a text child, that all gets one semantic node. The two pieces of text in the middle, they're each getting their own semantic node. That button down at the bottom is actually multiple widgets composed together for the shape of the button, that it's a button, the label, the icon on the button, and so forth. But that all gets one semantics node in the end. Accessibility can be free. So the Flutter framework has been designed to be accessible out of the box, right? There are all of the stock widgets that you'd want to use. As long as you're filling in the relevant properties, they will be accessible. So for example, on the screen now I have two different styles of button, right? That floating action button, and in the screenshot here I have the tooltip activated. You can see it says increment. The framework is smart enough to know that because you put the tooltip widget in here, it will create a button semantic node that says tooltip as the label. Similarly for our raise material button on the bottom, it says open on it, right? That open is a text child, but again, the framework's smart enough to know this is a button that should say open on it. Sometimes it's not going to come by default. If, for example, you have a really custom button that's just using a raw gesture detector, as opposed to using one of the out-of-the-box button widgets. Or, like some of our speakers spoke about earlier, if you're painting things directly on a canvas with a custom painter or something like a single child render object widget, in those cases, you're going to need to do a bit more work to tell Flutter how to create the semantics tree. So bespoke experiences need bespoke semantics. Just like as a designer, you're going to spend a significant amount of time thinking about how will my user interact visually with this app, right? What's it going to look like? How is this animation or transition going to work? What kind of motion am I using? We also want to think about how is a user going to interact with my app if they're using assistive technology like a screen reader, right? As an example of this, we took a look at the Shrine app from the new Flutter Gallery. And actually, this is somewhat similar to the Shrine app in the current Flutter Gallery. So if you're familiar with that, it's more or less the same. I have an animation up here of some interactions with the Shrine app. There is a drop-down menu from the top left that lets you filter different products. There's a list of products that you can scroll in the middle of the screen. And then down there at the bottom, there's a cart button, which if you have products in it, you can tap it, see what you've added, remove products, or clear your whole cart. At a very sort of boiled down, simplified level, we have a stack widget that has a fancy app bar with a drop-down, a special list view that gives us these scattered products, and a shopping cart, which can be expanded or collapsed. Right? Obviously, the real app's a bit more complicated than this, but for our purposes here, this is good enough. Now, we're going to want to look at how a user with a screen reader would interact with this. And Victor, you can tell us more about TalkBack.
So just for today's session's purposes, we decided to use a TalkBack, which is a built-in screen reader on Android. And you won't see me in that video, but you will see me using the app. And so a quick primer on how screen reader works. There's really few things you need to know. When the user touches the screen, somebody who's completely blind, they will hear spoken feedback, or they should hear if everything works right. When you swipe right to go to the next element, you swipe left to go to the previous element. And if you want to activate the element of your choice or that interests you, you have to double tap. So when we watch to go to the previous element, and if you want to activate the element of your choice or that interests you, you have to double tap. So when we watch a video of me trying to use in a Shrine app before any accessibility markup was applied.
Great.
Me trying to use in a Shrine app before any accessibility markup was applied.
Great.
Try my fashionable retail app. Double tap to act. Shrine, yep. Username, edit box. Password, cancel, button, next, button. Double tap to activate. Open menu shrine. Open menu shrine. Button. Heading. Double tap to activate. Search. Button. Double tap settings. Button. Double tap to activate. All. Search. Button. Double tap settings. Button. Double tap to activate. All. Accessories. Double tap clothing. Double tap home. Double tap to activate. Lookout. Double tap to act. Stella sunglasses $58. Button. Vagabond sack $120. Button. Whitney belt $35. Button. Strut earrings $34. Button. Garden strand $98. Button. Double tap to activate. Varsity socks $12. Gatsby hat $40. Button. Weave keyring $16. Button. Shop bag one. Copper white. Gilt. Super blues. Coron. Rain. Sub. Shell. Cork. Place. Kitchen. Sea. White. Plastic. Shell. Gentry. Jet. Sea breeze. Navy trap. Surf. Walter Henley. Gingers. Chevrolet. Ramona Crop. Classic white. Shoulder. Surf. Great. Fine line. Sunshirt. Back. Open menu shrine. Back. Button. Sunshirt. Back. Button. Double tap.
That was painful, right? Well, there are a few things that just happened. Well, actually, they didn't happen. Some of them did happen and some didn't. Well, the first thing you may have noticed is that when I was swiping between elements, I was actually going through some elements that I wasn't supposed to hear or see because they were actually invisible on the screen, and yet my screen was able to get to them. So that was not nice. The bigger issue was, well, the second big issue was that when I was going through the buttons, I wasn't exactly sure if I hit that button, if I double tap on it, what was supposed to happen, which visually you probably knew this clicking the button would actually add the item to the shopping cart. But that would be only part of the problem. The biggest issue was that I wasn't even able to get to the shopping cart. What's the purpose of this app, right? Really to get you buy things. And so Dan and the team take it from here.
Sure. So what can we do about this? Some of these problems are widgets that had properties that could have been set and didn't have them. So for example, we had an image in there at one point, it went pretty quick, that really isn't relevant to someone using a screen reader. Images have a property called exclude from semantics. If they're purely there for just sort of visual flair and they have no real semantic meaning, we should just go ahead and exclude them. We can use semantics widgets to specially annotate widgets that are otherwise not quite getting the right thing. This can be used to control things like sort order, whether or not something's actually a button, if widgets to specially annotate widgets that are otherwise not quite getting the right thing. This can be used to control things like sort order, whether or not something's actually a button. If it is a button, what do we want TalkBack to say it does when you tap it, right? Instead of just double tap to activate, could we make it say something better? Using merge semantics to pull certain nodes together that might have been separated. We didn't see an example of that in the video. Or using exclude semantics. Right? So a couple examples of what we went through and did to improve the screen reader experience. For that roll down menu of the filtering products, and that's what you saw, the screen reader was jumping to invisible elements. There's actually two ways we could have approached it. So I'll first talk about what we actually end up doing here, but I'll mention another. We use an exclude semantics, right? A stack widget paints multiple widgets on top of each other. And you can, based on the state, you can control where those widgets are positioned and whether they're going to animate in or out and so forth. We want to actually just exclude the semantics based on whether or not a certain property is set to true. So it's very easy here to just add exclude semantics widgets to our tree. And this way, when the menu's not visible, it will not be part of the semantic tree and it will not show up in the screen reader. Another strategy we could have taken here, and actually might have been a better one for this particular to control where those widgets are positioned and whether they're going to animate in or out and so forth. We want to actually just exclude the semantics based on whether or not a certain property is set to true. So it's very easy here to just add exclude semantics widgets to our tree. And this way, when the menu's not visible, it will not be part of the semantic tree and it will not show up in the screen reader. Another strategy we could have taken here, and actually might have been a better one for this particular example, is to just exclude those widgets entirely from the tree in this case, right? So only have that background widget there if we want to make the background part visible. But you can imagine cases where there's caching work being done there that you benefit from building it even before it's visible and so forth. And in that case, we still want to exclude the semantics so that the screen reader doesn't present a confusing or out of order experience. Another thing that we did is we realized that the cart, there were two problems with the cart. One, it wasn't reachable at all. It turned out that another member of the team, while working on the semantics for that back floating action button that you'll see again, they actually put the semantics node around something that ended up covering the cart, right? When they tested it for the back node, it looked like it was okay, but they never realized it ended up covering the cart. So that was one problem. Another problem was even after we got the cart uncovered so that it looked like it was visible in the semantics tree, it was down as the last thing. And you saw Victor had to scroll all the way through a large number of products, which could be sort of a deterrent to someone actually using the app going to check out. So for this, we used a sort order key, right? In our stack here, we have two semantics nodes with a sort key, one with ordinal sort key is 1, and then the second one that paints later and comes semantically later with a sort ordinal key of 0. This means when Flutter builds a semantics tree for this application, the shopping cart's going to come first, and you'll know easily how to get back and forth to the shopping cart. There are gestures in TalkBack that let you very quickly navigate to the first or last item on the screen. So with that, let's look at how our application changed after applying some of these fixes.
China fashionable retail app. Double tap to username. Edit button. Password. Cancel button. Next button. Open menu shrine. Shopping cart. No items button. Double tap to activate. Open menu. Open menu shrine. Shopping cart. No items button. Double tap to activate. Open menu shrine button. Edit. Search button. Settings button. Stella sunglasses $58 button. Vagabond sack $120 button. Double tap to add to cart. Whitney belt $35 button. Double tap to add to cart. Strut earrings $34 button. Double tap to add to cart. Garden strand $98 button. Double tap to add to cart. Varsity socks $12 button. Double tap to add to cart. Gatsby hat $40 button. Double tap to add to cart. Shopping cart 3 items button. Double tap to activate. Close cart 3 items button. Remove Whitney belt button. Whitney belt quantity 1x $35. Remove garden strand button. Garden strand quantity 1x. Remove Gatsby hat button. Close cart 2 items button. Remove Whitney Bell quantity. Remove Whitney Bell. Close card 1 item. Remove garden strand remove garden strand. Close card no items. Button. Total $0. Close card no items. Shopping cart no items. Button. Double tap to activate.
So if you have noticed with these changes, I was now able to, first of all, I didn't see those invisible elements, which was nice. I didn't care about them anyway in the first place. The second thing, I actually could hear really nice hints coming from TalkBack telling me to double tap to add to shopping cart, which is much friendlier than just saying to double tap to activate. That was really cool. But the coolest thing from TalkBack telling me to double tap to add to shopping cart, which is much friendlier than just saying to double tap to activate. That was really cool. But the coolest thing here, I was finally able to go find the shopping cart, and you notice as I was adding items to the shopping cart, the widget would actually reflect the number of items in the shopping cart at that particular moment. And when I opened the shopping cart and removed items one by one, that widget was also reflecting the number of items left in the shopping cart. So that was a much smoother, nicer experience. And if you wonder, the same experience will be available to anyone who is using voice over screen reader on iOS, because remember, Flutter is cross-platform, and so in that sense, we've achieved basically accessibility cross-platform.
Great. So how can we test with TalkBack? Maybe you're thinking, this is great, but I've never done this before. A really great way to start is just when you're going through your development process on a physical device, enable accessibility services. Turn on VoiceOver on iOS or turn on TalkBack on Android, and just see, what is this like? Is this useful for me as someone that's never even tried to use it before? It does have to be a physical device because the emulators and simulators don't quite provide the same accessibility experience. That's not so much a Flutter limitation as just the state of the world right now. Check your app with different text scaling options, right? In accessibility services on most platforms, users will have options to scale text up by as many as, say, 3 times. This is great for users that have, say, vision impairment or vision difficulties. What does your app look like when that happens? Are you seeing weird overflows that you weren't expecting? Is text flying off the screen now because it's bigger than you were anticipating before? Maybe you have a hard-coded value somewhere that you have to update or something that wasn't quite as responsive as it should be. And then write widget unit tests. Semantics are enabled by default when Flutter runs unit tests. This is not necessarily the case when Flutter runs on a device, right? We only enable the semantics tree if you have accessibility services turned on, like TalkBack or VoiceOver. Or on Android, actually, there are some other applications that may request the user turn it on for some other accessibility reason other than screen reading. If you never test with accessibility services turned on, at least your widget tests will, and it may catch issues that you otherwise would have missed. In particular, I'm going to highlight a few things here that the team has come up with to sort of help you determine if your widget is accessible or not. One of them is if finding a widget by semantic label. So you're probably, if you've ever written a Flutter unit test, you probably have thought of finding something by the text label, right? That's like find.text one finds one widget, right? That would return true for the screen up here. Find by semantics label increment will also return true because that button down there has a tooltip of increment. And this can be a great way to make sure that for a given widget or on a given screen, you can, a screen reader would be able to find the label that you're expecting it to find. Another good one is text contrast guidelines. So in particular, I'm going to highlight a few things here that the team has come up with to sort of help you determine if your widget is accessible or not. One of them is if finding a widget by semantic label. So you're probably, if you've ever written a Flutter unit test, you probably have thought of finding something by the text label, right? That's like find.text one finds one widget, right? That would return true for the screen up here. Find by semantics label increment will also return true because that button down there has a tooltip of increment. And this can be a great way to make sure that for a given widget or on a given screen, you can, a screen reader would be able to find the label that you're expecting it to find. Another good one is text contrast guidelines. So on the screen highlighted here are places where there's text, including the button because that's actually a font icon. This test will automatically rasterize the widget there and check if it meets, based on the WCAG accessibility contrast guidelines, is your widget readable? Is there sufficient contrast so that you meet those guidelines? Right? And this will basically just test the whole screen that is currently in the test. And then finally, we have some around tap target sizes. One for Android and iOS, which have slightly different guidelines on how big a tap target should be. So are my buttons big enough so that the user can tap them? This is going to be particularly important for someone with, say, motor impairment, or even if they don't have motor impairment, they have big, larger fingers, or they have trouble pinpointing a specific location on the screen with their finger. I have that problem a lot. There's also our tap targets labeled, right? When a screen reader comes to something that's tappable, it's going to say, this is a button, right? You want it to say, this is a button that does fill in the blank, or this is the button for. If you have a label on there, you're going to get a much better experience. If you don't, this test will catch. You have a button on in this widget, or a tap target somewhere in this widget, maybe use a custom gesture detector or something like that, and it's not properly labeled, right? So this is a great opportunity to make sure that you follow these guidelines and that you'll have a better experience for your users. Finally, where can you go to get help? So Flutter has documentation on accessibility available on our website. It provides a little bit more overview of some of the widgets I pointed out, like semantics and merge semantics and so forth, a little bit more information on how to activate screen readers on your chosen platform and how to test with them. There's also the material design accessibility site, which is, if you're using material design, great resource for how to make sure your components are accessible. And then finally, each other. We have a great community with Flutter, and we have some great community resources listed at flutter.dev/community, where we can turn to each other and look for help and advice, making sure we're designing not just for the visual, but also designing for all of our users and make sure we're reachable for everyone.
Yeah, and with that, thank you so much.
Thank you very much.
Boo boo. Where did the audio go? Let's see. I think I gotta open Firefox again. Oh, wrong thing. Um, Twitch. Gotta fix something. What was this thing called? Slofi. Oh, I can't find it. Can you zoom in a tiny bit? Can't see. Right. Is this better? Also, do you know the website for the Lofi, like the first stream? Lofi player something. I don't know what it is. Ah, yeah, Lofi generator. Thanks. I was trying to find it. gotta save it somewhere. Yeah. I'm gonna do that right now. Save. Bookmark. As a bookmark. Voila. Fixed. Alright, where were we? We were here. Above big card. Right. Removed. Big card size box. Right. Visual gaps, of course. That's about right. Oh, there's no padding in the one with padding. Where's the padding? Text. We can wrap this with padding. Wrap with padding. Or was it that one? I don't think we can see. Oh, it is. Did I not wrap it with padding before? I think I did, but no, maybe not. Alright, next. Full hat. De red verrent. Probeer. Hoedsake. Skin shame. Crossbird. Creature. Bolstra. We like the button. Scroll to my apps type. favorites, this column. Yes, sir. My homepage build. Yes, yes. Elevated button. Oh. With a row. Wrap with row. Yes. I'm gonna add the like button. I like it. Right, elevated button. It is Dart. Main.Dart. As you can see. Looks kinda like Java, not gonna lie. Yeah, it's very similar to Kotlin, and Kotlin is also very similar to Java. As you can see, this is Kotlin. Wait, if you go to, for example, machine, let's go to machine. They're also using Oh no, that's the wrong spot. Machine screen. Like here. Scaffolds. In Dart. Also scaffold here. And also the same kind of way with rows and columns. Like, which happens here as well in places. I think scaffold is just a container name. But it just looks very similar to Kotlin, Dart. Like here as well. Cards and childs. Yeah. Exit. Oh, yeah, this one. Spoilers ahead, of course. Mm-hmm. 55 words per minute. Nice. Let me see how much I can do. Wait. Monkey type. Wait, we gotta focus up now. I'm not warmed up. Already immediately 40 though. Since I recently switched to Comac DH. Already a lot better. 50. 48. Mine is only on 5 letters or so with 10 fingers. That's what I get 55 on, so. Oh, you just keep on typing, son. Keep on typing. And you'll improve. In no time. What was this sized box? So note that the use of side box to keep the two buttons a bit apart. So it's like a gap. Gap. Oh, we got the icon. Icon data icon. Yeah. Okay. Yep. Bull straw. The Death Star. Coach truck. Full staff. Mean plot. Greek fence. String tier. Tried moon. Right. Next. Delete it. Delete my home page. Okay. And replace it with the following code. Okay. That's beautiful. Okay, what happened? Safe area. Yeah, navigation rail. Navigation destinations. Generator page. Never mind, just unlocking new letters. The software has decided my level is high enough. Was just getting comfortable with my 5 fingers. With my 5 letters. Yeah. What am I trying to build? I'm trying to build this. Just get started in Flutter. You just following tutorial. At the moment, I'm following the tutorial, but I'm gonna create this. So like inbox. Yeah, basically that's an example app I need to create. But to understand Flutter, I'm just going through the tutorial. Up until now, everything is pretty easy and pretty similar to Android and Android Studio with Kotlin. So I can see lots of like similarities. For sure, it isn't that difficult. Alright, let's read when you see. Click the heart. Yes, because the other page doesn't exist yet, of course. Okay. Alright, yeah. The scaffold stays in the home page. Mm-hmm. The button disappeared. Mm-hmm. Okay. Expanded. Primary container. So it's like a wrapper. That's what I'm thinking. So it's not a wrapper. Expanded. What was it before? Just control the primary container. They let you express layouts where some children take only as much space as they need. Okay. Ah, okay. I think I get it. And, yeah, okay. Is there an expanded here? There is not. Wrap with widget. Yeah. Yep. Yep. Boing, oing, 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 oing.
just provides a little shader or a little oh, that's it. You did it. We've covered all these things. We've covered the basics of how Flutter works. We've covered creating layouts, connecting user interactions. That's the, like, you know, if you click on this, something happens in the app state. We talked about extracting widgets, which is a big part of keeping your Flutter code organized. We talked about making your app responsive, at least a little bit with the layout builder. And yeah, we used themes, so we achieved a consistent look and feel of our app. Just to get back to kind of hammer it home, now that we have all of this, I can change it to green, right? Or I don't know, and save. And now this is green, this is green, this is green, this is green. Everything is now green, and everything is in the same color scheme.
Alright, ladies and gentlemen, gonna end the stream there. We went through the tutorial. Maybe tomorrow we can see to make the actual thing. Why are you making an inbox app? It's for preparation for internship. To learn Flutter before starting the internship. So I need to make something basic. So now that we've gone through the tutorial, tomorrow we can start making it maybe. And dive deeper. I have an ID. What is your ID? If you want to make something. What do you want me to make? I'm first gonna do this, of course. This doesn't seem that complicated, but yeah. And then, what's your ID? Or you want me to come up and hear it? A place to save many film. Ah, yeah. Fujifilm camera and share with others. Yeah. Alright, I'm gonna end the stream there. No good solution that exists for it yet. Yeah. At least as an app and a website. IT.